Hello. Thank you everybody for having us on again. We actually did this presentation at US, so we figured we'd bring it over to EMEA. So this is going to be a little bit different. Most people here may or may not know that Cohesity actually last year built an 18-wheeler. We built a rolling data center that we do mobile EBCs and customer events and partner events.
We didn't actually build the 18-wheeler.
We didn't build the 18-wheeler.
That would have been weird.
Yeah, we leased the 18-wheeler. We built the data center. So we're actually going to, John Hildebrand and I did the entire build out on the data center. So what we wanted to do is, from a technical discussion, we had a lot of really interesting design challenges with this. So we figured we'd bring it out to the community just so we could show people what we had to deal with, right? Because I don't know that I've met anybody in my 20-year IT career that's actually built, a data center that has to go down the road, across the country, and be powered on and shut down 27 times a month. Most of us don't shut our data centers off.
Unless When's the last time you guys shut your data center off? Just turn it off. Intentionally, not the janitor that walked past and hit the button and you're like, oh, good Lord.
So we'll walk through some of the stuff we had to deal with, and I apologize for my voice because it was a long night last night, I think, for everybody. So why did we do this? I'll give you the story that I got, which was I joined Cohesity in August of last year. We had sales kickoff when our CMO announced at sales kickoff that she was basically going to do this project. I met her a week after I joined the company, and she looked at me and said, "You're going to build my truck."
I think her words were, truck? Hey Chris, I bought you a truck.
Yeah, she said, I bought you a truck, so have fun. But the idea behind it was, one, it's a giant mobile billboard, right? So when it's going around the country, you know, it's advertising for Cohesity. We do use it for some basic proof of concepts to drive pipeline. Partners are leveraging it at partner events, which is really kind of cool because they'll bring their customers in. And at the end of the day, we're making about 120 stops a year over 2 years. We don't really get into the financials of it. We can talk about that afterwards, but there is some interesting things with insurance and driver fees and fuel because we actually run the whole data center off of a generator as well. So we'll talk about that in a second. So there's no shore power, 100% generator driven. So what is actually running in this beast? And there's actually been some updated pictures over the last couple of months because we are constantly doing maintenance to it, but this is just a rough idea. So we had literally went and decided we were going to put in about 20 different Dell nodes. We have NSX running. We have the entire vSphere stack. We actually started a vCloud Director installation to highlight the VCD integration that we have. We run everything off of Active Directory. We'll get into the networking because I think the networking for me was probably the most difficult thing to figure out because I'll start throwing some questions at you to make kind of your heads hurt the way mine did. But how do you manage an environment that doesn't have always on internet connectivity when a problem happens, when you need to actually get into it? Or better yet, how do you actually get to the back end side of it when the vSphere stack isn't even running yet? So we actually had to make a design decision whether we ran heavy NSX throughout the whole thing and relied on that, or we actually relied on standard switching and VLANs and things like that so that we could get to the backside of the network and actually get to iDRACs and things like that. How we get to it is a different story. But at the end of the day, it's a very heavy environment. I mean, it runs a lot of infrastructure. One of the things we wanted to do was make sure when people...
Heavy, I think the one you need to see, make sure, truly heavy.
Truly heavy.
Are these guys?
Yeah, so I think I might have a picture of those. So if you haven't ever seen a 19U APC, well, let me rephrase that. If you've never actually lifted a 19U APC, it's not fun. And when you have to lift it up into a trailer, then get it into the racks, then load the batteries, then load the fans and everything else, it was physically exhausting. So we took about 8 weeks to build this truck, and it was done in 8 weeks. Start to finish, wrap, everything. So actually, here's some of the photos of it, but I mean, we just had pallets of stuff showing up. So this is how you get an APC into a trailer. You cut the pallet, and you put it on a forklift, and you very carefully feed it through the door so that 2 other guys can grab it and shimmy it into the rack. So one of the most impressive things was our network guy, Michael Jang, is a cabling master. I mean, the back of these racks are laid out really, really well. So this is actually what it looks like. So in the back of the trailer, you have 3 racks, 3 glass doors. There's actually been more gear put in since then. But we had to, so the reason for the massive size of the APCs is because of the generator power. One, we can't guarantee how clean the power is, even though it's a diesel generator. It's a 100,000 watt generator. It runs the whole trailer. It runs everything in it for power. It runs the AC, the cooling. So there's actually separate cooling in that back room from the main part of the trailer. So we needed to make sure the power was clean. And two, if we lost the generator, which has happened 3 times.
Including while we were in the back of it working on it, and all of a sudden it just
in a parking lot in New Jersey. Story for a different day. But we needed to make sure that we had enough runtime to let the driver troubleshoot the generator, because the driver owns the generator, or doesn't own it, but it's his job to work on it. And if he couldn't fix it within a certain time frame, that we could start a shutdown and bring everything down. So we have an hour of runtime off of those 2 APCs with the amount of battery that's in it. So we are actually at max capacity. We get requests all of the time to add gear to the truck. So once we built it, vendors came to us and said, hey, can we put more Cisco? Can we put more HP? And our answer is, we have no more power and we have no more network ports. It's done. There's just nothing else we can fit in it. So actually
You're
today,
welcome to put it in if you just want it to sit there and not do anything.
and we do have 2 HPE chassis that are just dummy chassis with bezels on them. So
they had to go find just the chassis.
Yeah, we had to
so they could put a bezel on the front of it to make it look like it was there.
Right. The whole inside of it's been wrapped. This was a networking discussion with Michael and Jon and myself. So really, we have a lot of pictures of this thing when we built it out. So here's kind of a logical way we laid out the architecture. So there's 5 demo stations. So when you walk in the truck, there's 5 individual demo stations. What we wanted to do is we wanted to actually leverage microsegmentation and some functions in vSphere to make sure that if demo station A blew up, it didn't affect B, C, and D down the line. Very different than the way we run our booth. We run our booth on a shared infrastructure. Everybody's doing demos off of the same clusters, the same hosts, everything else. In this environment, we actually built out a vApp, a vSphere vApp, and cloned it 5 times so that we didn't have an issue, because we can't work on it every day. If one of these demo stations fails, we don't get a chance to work on it for 3 months. We can do some remoting in and some other stuff, which we'll talk about. So we actually did build it off of NSX for that reason, and we did use microsegmentation and some cloning tactics and a few other things, just so that we had these pods, right? We literally have these 5 different demo pods. But we do run everything else in a management cluster separate from the compute cluster. So this is a little bit outdated, but this is how we built the network infrastructure. So behind the racks, there's 2 Cisco 9Ks, 10 gig switches that are our cores. There's 2 Cisco 10 gig 3Ks, 2 Cisco 1 gig 3Ks, and then another one that runs the desktops. There's about 5 different VLANs. We have 2 back-end networks. We have what we call our 5 VLAN and our 10 VLAN, which are our out-of-band management, and then our management network. Those are fully accessible over a VPN through a 4G connection. We actually had to go to the service provider, which happens to be a company called Verizon in the States, and we had to pay separate for a public IP on a SIM card. It's not cheap. It's fairly expensive.
And they really look at you weird when you're like, I need a public IP for my phone.
Yeah, for a phone, basically. And by the way, when you walk into the store, like the actual retail store, and you try to ask those questions, they have no idea what you're talking about, because they just want to sell you a phone. They're like, I can sell you a phone. And we said, we don't need a phone. We just need the SIM card. So what we actually have is, there's a company called, we had to do a lot of research. There's a company called Cradlepoint that makes hardened routers. And what they are is they use them in emergency response vehicles, SWAT vehicles, military vehicles, things like that. And they have dual SIM cards. But that's all you do is stick the SIM card in it, and they will actually fail over between 2 different providers. They do handle Wi-Fi, they do some other stuff. But that's our gateway out. And we can VPN in through that when it has a decent signal. Most other times, when it's at the shop, we do have a hard line when we do bring it back to San Jose to work on it. Another interesting thing about this is our storage is now a Nimble. We do swap things out every once in a while just for marketing purposes, things like that. We actually had to do a full storage swap. We had the Pure in there for a while, and then HP wanted some visibility. We literally ripped out the storage over 3 days and put a new storage array in. We did a full migration. We had a very short timeline to do that. after that, it's real basic stuff. We use our Cohesity chassis because they have the Cohesity logo on them. We could use any of the other chassis we're certified on if we wanted to.
So what about the redundancy between the two and what it's like riding around in the back of that thing when it goes down the road?
Yeah, so we were told when we designed this to imagine a 6.0 earthquake for the 6 hours it's driving. So the whole time this thing's going down the road, it is banging around, right? We had to, when we started racking stuff, the rails actually started to bow out because of the weight of all of the hyperconverged chassis, which this rig was somebody else's rig. So the trucking company built it originally and then we released it. But when the original company used it as an old data center, the stuff wasn't as heavy as it is now. We had to stop work, bring in pipe clamps, bring the rails back together, put in reinforcement horizontally so that we could keep everything from moving left to right. The other thing we found was with the Dell chassis, they don't have what I call front to back rails. So they're basically the rails go in and it's just a shelf, right? So you slide the chassis in, and if you go to the back of it, you can still lift it up, but the front actually bolts in. So we had to fabricate shelves to go in the back of the rack to push down on the chassis to keep them from bouncing in the back. It's those things that you don't think of, that what happens when this thing's going down the road. Now, it's not powered on when it's driving, so none of the spinning discs have an issue, none of that stuff. But just the sheer bouncing around, we've lost two switches.
Yeah, and the switches were more things literally would bounce off the boards.
Yeah, we actually...
Like they open it up and Cisco's like, yeah, this is no longer attached.
Yeah, we've had Cisco ask us some really interesting questions what we're doing with their switches. And when you call them and tell them that we need parts and you have to ship it to a hotel, but it can't get there till a certain day, support calls are just very, very interesting. So I'm going to hold on this slide for a little bit because this is John's favorite slide. He loves his little blown up emoji. But when we walked through design consideration and we started whiteboarding this thing, so what is the two things that every environment needs to work? And what are the two things we usually blame when it doesn't go right? DNS and time. So I always love posing this question to people. We're so used to getting NTP services from the internet, from our network teams. What if you don't have the internet?
How do you get time?
Where do you sync your time? And we ran into this because everything failed at one point and we realized it was a time issue. Everything was out of sync. And that was John, because we sat at the whiteboard one day and I looked at him and I said, so hypothetically speaking, we go somewhere, the 4G connection isn't stable, we don't have internet. When all this stuff boots up, where does it time sync? I seriously thought I broke him because he started pacing around and he said, I don't know what we're going to do. And we were just getting into the build. And we flew home. I flew up to Seattle, and I was sitting with a friend of mine who works for VMware, and we were having a beer one night, and I posed the question to him, and he goes, well, there's got to be something. He started Googling. He's like, did you...
He actually said, did you Google
He said, did you Google it? And I went, well, no, not yet, admittedly. And he pulled it up, and what we found was a company called Time Machines. Swear to God, it's the name of their company. They make a solid state box about this big that uses a satellite GPS antenna and does nothing but get time from 36 satellites. So we bought 2 of those to the tune of $3,000, overnighted them while I was in Seattle so that we had them on Monday. And in order to test them, satellite connections don't generally work inside a giant garage where the truck is parked. I'm outside by the dumpster with one of these satellite antennas stuck to the side of the dumpster connected to my laptop to see if this thing actually worked. And it's phenomenal. It's one of the first things that actually boots up in the back of the truck, and all of the hardware gets all of its time from GPS. So it doesn't use any internet connections to get time sync.
But it did mean we had to have custom mounts for those antennas.
We did have to fabricate mounts on the back of the truck. So we would go back to the shop guys daily and just with these crazy requests. And one of the guys, Rick, who when we go back there, they're kind of like family, but he's like, you don't need anything today, right? Like, you're done asking me for weird stuff because this is already nuts. And they do this stuff all the time, but that was one of the big ones. The power considerations we talked about a little bit, but is it clean? Will it run? We have run out of fuel in the generator. It runs off the tanks of the truck, but when the parking lot story was, we were working on it, but the truck was not on. So the cab wasn't running, which meant that the 12-volt switch for the crossover pump to go from tank A to tank B wasn't feeding fuel across the tanks, and we drained one of the tanks. And literally the generator just shut off.
So the generator shuts off. We call the driver of the truck company, and we're like, guys, the generator stopped working. Is it out of gas? They're like, we filled that thing. There's what was it? 100 gallons in it sitting there?
200 gallons per tank.
Sitting there waiting for us. And they're like, why is it, what are you talking about? It should be working fine.
He didn't flip the switch.
Literally, you had to turn the cab on just so it would start the fuel pump and flip it over. And then magically it started working again.
Right. This one I'll talk about. So startup and shutdown procedures. I mean, a lot of folks use PowerShell in the audience, I hope. So John Hildebrand had to develop PowerShell scripts. So I said we shut this down. We fully shut the data center down and we fully power it on every time it makes a stop. Well, we did not want to have people walking around pushing buttons. So we had to figure out the run book of what had to be physically powered on, and then what could we do via automation. So the very first part of the procedure that happens is there's literally 200 amp breakers in the belly box of the truck that the driver turns on. So these breakers are not on while it's driving. He fires up the generator, he throws 2 breakers. Those 2 breakers power the 2 APC units. Those 2 APC units start to bring up the switching stack because they don't have any power buttons on them. So the switch stack, routers, the time machines, all of that stuff, the AV equipment, all of the hard, the solid, essentially solid state stuff comes up. He then has to wait 15 minutes to make sure that all of that stuff comes up. This is all in the run book that we wrote. And when he walks up to a single Mac Mini in the back of the truck, there's 2 PowerShell files. One says startup and one says shutdown. The driver of the truck runs both of those scripts, not an SE, not a technical resource, the driver. We simplified it to the point where he double clicks the startup script and it goes through and does all of the checks. It checks for all of the Cohesity nodes to come up. Actually, he does power up the Cohesity nodes. He does. He physically powers up the Cohesity nodes and one single ESX node at the very top of the stack. That's when he waits 15 minutes. What those scripts actually do, what John developed in the PowerShell scripts, was a timed-based runbook that goes through and checks, can I get to my IPMI nodes on the Cohesity side, on that back-end network? Can I see IPMI? Can I see iDRAC? Can I see IP addresses coming online? And as it goes through and sees that everything's alive, it starts to fire off Redfish API calls to the Cohesity side to bring those online. And then it fires, or maybe Redfish to Dell, I don't remember. But he actually does all the power-ons for the rest of the Dell servers through the IPMI API, or through the Redfish APIs. What we also had to develop as we went through this is what happens. So all of our back-end management interfaces, you only get one management interface, right? You get one iDRAC interface, but you get 2 of everything else. So we have half the servers on one switch and half the servers on the other switch. Well, the switches that fail are always the IPMI switches for some reason. So at one point, the scripts went haywire and just didn't work because we then had to add steps into the scripting that said, well, wait until you see at least half of the servers available, because it's pretty obvious. If one switch fails, you lose 10 nodes, right? And you lose 8 Cohesity nodes. So we could still run the truck now if a switch fails on all of the scripting and everything else. We also even power up an Azure-based, I'll say Azure, there's a partnership now. We power up an Azure-based version of our software for the SEs to actually do cloud-based demos. So we use Azure's API as long as it sees internet. If it doesn't see internet, it skips it. So there's a lot of checks and balances in these scripts. I think John is actually trying to scrub them a little bit and get them out on GitHub so people can see some examples of what he's done, which I think the work that John has done on just the startup and shutdown alone is phenomenal.
Well, and I think there's things that you don't think about if you're going to shut it down and you don't know. So it's making sure all the machines, you shut them down in a certain order so that your management machines, things like your NSX manager and things, all go to a node that you know what node that is. Yeah, you need to know what host those are on. So when you can power back up, you can actually manage them.
So does anybody actually use, the auto start procedures in an ESX host anymore? I do. I have to. Because when he powers on when the driver hits the button on that first Dell host, we back out all of the hosts from the reverse order. So DRS basically moves everything down the stack back to the first host. Then there's 6 machines that are 6 VMs that are configured for auto start, which would be your obvious ones: Active Directory, NSX Manager, vCenter, all of the things we need to run the infrastructure. That way, John can run his scripting, which then calls the vCenter APIs at that point. So we haven't figured out what happens if we lose the first node. It hasn't happened yet. And it just needs to go for another year, and then I will probably still never have any hair. But it really, you don't think of a lot of these unique situations. I mean, I think there's been a lot of folks that have built dark sites and things like that, but I still don't think they turn them off. I think that to me was the biggest.
Well, I think one of the other things that was a challenge on that remote support. So all of the demo stations are running Mac Minis that they're connecting back through Horizon.
No.
They're not connecting Horizon, you're right.
I thought you were here for moral support.
You're right. So they're connecting back through, but what do you do if you have an SE working on a station, they have an issue, the truck driver's not going to be able to help them with it? How do I get onto that Mac to see what they're seeing to be able to support them with a 4G connection?
It's slow, but it works, and that's what happens. A lot of times, John, we use FaceTime a lot. A lot of times there's a FaceTime call with an SE, and they're holding the phone up to the screen so that we can see what's happening, so we can troubleshoot it, because we own this thing. Like our team, because we built it, we have to support it, we have to take the calls, and it's predictable because we know the days it's coming online, we know the days it's going offline. We've actually hired another team member, thank God, to help with this, because what would happen, there was a situation where something went completely awry. I don't remember what it was. You were doing
a switch.
We lost a switch. You were at a trade show. John was on a plane. I was doing a speaking engagement, and Teresa was with a customer. Nobody was available out of all 4 people. So we basically had to tell them, just sorry. Yeah, we don't really have an SLA on it because we can't guarantee how quickly we can fix it, how soon we can get to it. So let me talk about the maintenance cycle. So we really only do updates to it every 3 months. It has to be stopped, it has to be parked, and we get 2 weeks every 3 months to do basically patch management, upgrades. For us, most of what we do is this, right? Because we're doing demos, so we have to make sure that the Cohesity software is at the latest version so that we can demo our latest features and things like that. We don't really worry about the ESX version as much. I think it's a little bit off of our other data center, but it runs 6.7 update 3, I think is what we have, and NSX is up to date and things like that. But we don't even bother, I hate to say, we don't really bother patching the Windows VMs and things like that because they don't have any internet access. If I go back to this stack here, everything in that VApp actually has no internet access. That's why it's all self-contained. So the reason for that, I'll actually tell that anecdote. We were in the truck one day and we were bringing everything up, and as we were bringing stuff up, the internet connection was getting slower and slower and slower to the point where it was unusable. So John and I do a lot of troubleshooting, so I said, well, wait a minute, let's start backing it back out. And as we backed it back out, the internet connection got better and better and better. So we scratched our heads a little bit, and what we realized was within that VApp and all the Windows machines, there was a bunch of auto updates. There was just a ton of internet traffic just going out and trying to pull stuff down. Actually, we isolated it down to the Windows 10 machines and the Windows Store. Apparently, there's a whole bunch of traffic on the Windows Store. So the other advantage of having NSX was we have a firewall. So I like to write firewall rules. So I just went in and said, everything from this VXLAN or from this vWire, kill it. So if they need to do any cloud demos, they actually have to do it from the Mac Mini desktop. They have to do, because those actually have internet connectivity. But if we had let it roll with that, and we hadn't found that, people would have just been, it would have been unusable. You just wouldn't have been able to get any work done. At one point, we did have a separate PSC. We've consolidated that. That actually needs to change on the diagram. I'm trying to think of what else was really, usually John and I have a lot of, like, the
horror stories.
But if you've never worked for 8 weeks in the back of a confined space with the same individual for that 8 weeks,
you're either going to like them
or you're going to kill each other. And I will say that John and I had, there was at least 2 knockdown dragouts between us and the network guy, because we were rolling it out, so we were just about done. John was testing everything. The first trip for it was Vegas, and this is where I'll kind of end on where we really did lose it. We didn't have our second core switch in. We had one Cisco 9K, and we were running with another loaner switch. The network guy decided to replace the core switches while we were in the conference room, and he yanked them out while everything was running. The entire thing went to hell in a handbasket. and it was 3 days before we had to roll it to the first show. And there was yelling, screaming, threats of violence. We did not let him back in the truck for like a day. I flew out and he saw me, and it was just, we just passed in the hallway and he would not look at me. So I think that's probably where we'll end, but it was probably the most interesting project I've ever worked on. I've told Cohesity I will never do it again. I've had other people ask me if I would build another truck, and I've said nope. I'm done. One time's enough. Put that one off my bucket list. It was never on it.
Yeah, that's no.
But I'll be around if you have questions afterwards. You can come by the booth and check out some of the demos that we have at the Cohesity side. So,
Awesome. Thank you, guys.
Thank you.